right, so now that we have our routines in there, we talked about kind of the bit levels and we talked about some basic instructions. We want to go ahead and talk about the one component that we haven't really addressed yet. Now, we've laid everything out the way we have so far on the HMI so that we have a base understanding of our process, right? But we don't have start buttons, we don't have stop buttons, we don't have basic controls. We haven't added any of that yet, and you probably have been asking yourself, well, are we going to add it or what? And we, at this point, if you are already ahead of the game and you ask that question, yes, we are going to add it. But I wanted to first, the reason why I'm doing this in this structured manner is to give you a base understanding of like doing this without a set of scope of work or a set of drawings and that matter. So, right, we are doing a set of training right now, so the best implementation would be to draw it out for you, give you an understanding of each tank, each pump, each component that we are going to program, and then come back and program it later. So we're going to have it later in the program. We're going to go back to our HMI and we're going to add our start buttons, our stop buttons, our different controls like our flow meter outputs, different components and stuff of that nature. So with that said, it's fair to say that in the routine level, some people or some engineers would be fair to say, or some OEMs that you would see would be fair to say that they would have a routine called HMI controls or system controls of that nature. So this would be to indicate the simple fact of, is there some kind of where's the input demeanor or where's the input devices going into the PLC, and then the output devices going to the output of the PLC, right? So some people even go to the extent of saying inputs in one routine and outputs for actual hardwire inputs and outputs. Now, I don't tend to do this because I think this is better to do in a routine level, to call out each independent area. This is the reason for this is because when you think about it, if the person behind you, if say for instance, if the person like a maintenance technician or engineer or operator or process engineer or process operator goes and has to work in that specific area, say the pre-mixing area like I have highlighted right here, then if they need to, they can easily pull up that pre-mixing area in the PLC program and visually see everything that's inside of that, right? So if they're having a problem, they can physically have their laptop in that area and actually be online with the program and see the components live in real time and actually see the program and easily go to it right here. So they can say, oh, everything I need to know about the premix area is right here. Everything I need to know about the mixing area is right here. Everything I need to know about the finishing area is right here, right? So this is the reason why I do it this way. It seems to be a really, really good component to having a real world working device with your HMI controls being user-friendly for your operators, and your PLC being user-friendly for your technicians, your electrical techs, your process engineers, and your electrical engineers. So with that said, we're going to add another component. We're going to add another routine, and we're going to call this _0. And we're going to call this batching or batch. Call this batch controls. So if my fingers will do the typing, we'll call this batch controls. Okay, so we'll add this in here. Now that's going to add up top. We're going to delete this. We're going to come back and program the rung in a little bit, but right now we're going to go ahead and back into our main routine. This is the reason I'm doing this in this order, so that you go back and you think about the routine level, right? Remember, the flow of the way the system scans is the task level, the program level, the main routine, and then you JSR to the routine subroutine, right? So we're going to come in and add another rung. We're going to add our JSR. Okay, so what I'm going to do too is be helpful on this is I'm going to increase the visibility right here. I'm going to increase the view, so that way you can see what I'm doing a little bit closer, right? And all we're doing is linking the main routine through the JSR. So we're going to quickly finalize that, because all we're doing is a simple, edit. And then we're going to drag this up top to get it. The only reason it's perfectly fine to leave it at the very bottom, but let's just say, let's cancel this edit right here. And let's show. So if you think about it, if somebody were to come in here, it would work perfectly fine for the program to actually get, you know, the scan of the process being able to be scanned right now. The batch controls would be able to be scanned right now. But if somebody goes behind it, they'll be like, why does it say 1, 2, 3, 4, 5, and then 0? It just logically, it would kind of throw them off. So what I would do is I would just move this up top, finalize it one more time, and that way it's sequential, right? If you look at it over here, it's 0, 1, 2, 3, 4, 5. Look over to here, it's 0, 1, 2, 3, 4, 5. Very, very, very simple concept, but it would work either way. Doesn't matter, but I'm just trying to stop the flow of somebody saying, oh, why is that done that way? So when it comes down to it, and that's always going to be the case, generally speaking, you can program a million different ways. So it depends on who's programming, how user-friendly they're programming it. The more user-friendly you program it, the more time you're going to spend doing it, right? So we're going to add a couple rungs in here, and I'm going to just throw in 3 rungs. And we're going to go sort of fast here so that you understand. So what we're going to do is we're going to add in a examine on. We're going to make a new tag. So I'm right-clicking. I'm going to new tag. I want to quickly talk about the components of making a new tag. Now we talked about the tags being basically tag based, right? So tag based meaning you type in what you want the tag name to be. In this case, it would be HMI batch start PB. And I'm saying this is the HMI, coming from the HMI, batch start push button, right? So I'm basically abbreviating that a little bit, but when it comes down to it, you can see that. So this is, you can throw in the actual, be really, really, really specific when it comes to what the tag name is. And as much as possible, even if you have to, you know, shorten it by acronyming it, making it the word shorter, but that way you can have it described out and you don't need any kind of descriptions right here. You can have descriptions. You can say this is the HMI start push button. So you can do that, and you can have that in there. But the problem with this is if you ever have to upload later and you don't have a copy of the program, you're not going to get this description back, right? Now, generally speaking, the programs are getting better. They're getting more fluent. The cache is getting better as far as that goes. So they do of caching of computers is getting better. So they may end up getting to this point where, yes, this does come in. But if you had to walk up to the component right now, or the controller right now with no program, you didn't have a copy of the program whatsoever, and you had to upload, you would not get this description. So we're going to assume that we don't have a description. We're going to come in here and make all of our tags described out to exactly what the component they're going to be doing is, right? So I know from my instance that this is coming from the HMI. It's going to be a batch. It's the start push button. Really, really, really simple. Hopefully you got a lot out of that, understood exactly why I'm naming my tag that way. This tag type is a Boolean. It is again, that is a 1 or a 0. And I want to highlight too, now this is another key component that a lot of people miss. The scope. The scope of work, right? So the scope of where you're wanting your tag to be interfaced with, right? So in this case, it's going to be interfaced with the program, or the actual controller level, which is in our case is the batching station project. Now you can go to the program level, right? You can go to the program level if you want to, which is the program levels up here, right? But if you do the program level and you try to use it in a HMI, you're going to have to make the path longer on the HMI tag, which is very easy to do. It still works, but it adds a little bit of complexity to it. So you'll have to call out this shortcut. You'll have to call out the program that it's actually talking through, and then the tag name, instead of the program shortcut and then the tag name. It's just little, it cuts out one key, like little middleman in that process. Now I will say there's a lot of elements where using program tags are very much a fluent thing to do. In this case, we will be doing both. So I'm going to show you anything that I'm doing, just talking back to the HMI, I'm going to make as a scope or controller scope tag. Okay. All right, so we have our button in here, right? So what we need to do now is come over here to our next section, and we're going to add an OTE, right? Have our OTE in there. And in this instance, what we're going to do is we're going to call this the batch start. Or the batch, this is going to be batch initialize, right? So what we're doing is we're going to say this is batch initialized, and in this instance what we're going to actually do is come back and have this as a actual let's see, right here we'll come back and throw this over here. So we'll add another examine on, and we'll come in here and do the batch right here. We'll just drag this over here, batch initialize. And what we're going to do is we're going to add in a one shot. Okay, so the one shot is very this is something we didn't discuss the way we discussed the way it works, but we didn't really get into the detail. So what I want to explain to you here is if this bit goes high, then this will go high one scan rate. So one time of the process of the processor scanning, right? It won't stay that way. It will stay highlighted, but it will only work one time. So it's a very cool feature, right? So we'll call this, and we're going to name this actual tag. We're going to call this batching. Let's see, batch. Sorry about that. The whole little typing. My fingers aren't working for me today. I don't know why. Call this batch controls, and then we'll call this ons. So what I'm doing is I'm saying batch controls, and spell controls right. So I'm saying batch controls, and I'm saying ons. So being that the instruction that I'm using is an ons, it's a one shot bit, right? It's not a one shot rising, it's not a one shot falling, it's a one shot. Being that it is an ONS, right? It's an ons. I'm going to actually use that as the tag, or in the tag, so I can indicate, okay, this is batch controls, this is where it's going to be used, and this is going to be the actual instruction. Now in this instance, I'm going to give myself an array of information. I'm going to give myself, this is where you can actually come in, and I'll show you that too, where if you didn't catch that, in data type, you can go to this little this button right here, this ellipse button, and it pops up, and then basically you can change your dimensions of how many elements of this specific instance you want, right? In this instance, we want to have, let's just say 10 of these, right? So let's just drag this and say we want 10 of these, and we're going to come in here and create this. Now we need to come in here and define which one we want to use. So in this instance, I want to have, so I have a lot of these I can actually use now, right? So I'm going to actually use just number one, right, or 0 right here, right? This would actually be number 1 in the actual, so you have 32 bits. If you think about it, bit 0 is actually utilized as, 1. So bit 31 would be 32. So out of 0 to 31, you'd have 32 bits. So if you do a dimension of that, that's basically showing that, how to break that down, right? So when it comes down to it, what we want to do now is we want to actually come in and do our timer. So we're going to do a timer, and this is going to be our batch start. We'll call this delay time. Actually, let's call this request time. And then now I want you to, we haven't talked about timers that much, so I want to talk about timers just real quick. So this is the timer on, and there's a timer off, and then there's a retentive timer. Now the timer on is saying anytime that the examine on is actually, the rung is true, so the flow of energy is from left to right, so it's from left to right on ladder logic. Now in different program languages, it's different, the flow of energy is different, but in this instance the flow of energy is from left to right. Now in this instance, if the timer on delay is actually active, right, that means the bit is, the actual rung is true, then the timer will be functioning. Now in the opposite of that, let me see if I can get it to pull up. if the timer off, as soon as the bit falls inactive, then it would actually be active, right? So just to show you that. And the timers in Control Logics are in Studio 5000 or in RS Logic 5000. They operate in thousandths. So if you think about 1000 would be 1 second. 2000 would be 2 seconds. And if I wanted to, 2500 would be 2.5 seconds. Now if I shorten that up, this would be 1/4 of a second, and this would be down in the milliseconds. So they are in the thousandths. So when you do a timer, just note that it is in thousandths. So if you want it 1 second equals 1,000, right? So it's really simple as far as keeping that in mind. So just to make sure you're well aware of that. So in this instance, we're going to actually jump around, and we're going to have a rung, and we're going to do another bit, and then we're going to come in and do the timer on delay. And the timer on delay, we're going to actually utilize the timer timing. And the only reason we're doing this is so that when this comes on, this batch initialize, when it comes on, it's going to do this it's going to indicate this one shot one time. And then as soon as that comes on, it's going to do for one scan cycle, it's going to latch in this enable bit, which is going to start the actual timer timing. And this timer timing bit is what we can use to seal that in. So it will finish timing to the 2.5 seconds. I'm going to change this tag up here too. So if you ever wanted to come in here and change the tag, you can as well. So I want to change that to start batch start initialize. So you it's better just to interpret that way. Again, the better you can get your tags descriptions or the tag name to match your description of what it does, the better it is, right? So in this instance, we now have our start button. We have we're indicating basically a one shot, if you would, or we're indicating how long the person pushes the button. That bit will stay on for that long. No matter how long they keep it on, if they keep it on for 10 minutes, it doesn't matter. It's only going to indicate one time, and then it's going to seal this in for 2.5 seconds. Now in this instance, what we want to do is come in and use the stop or the done bit. So we're going to utilize the same timer. We're going to utilize the done bit, and the reason we're going to do this is we're going to give a single scan of when it's done. We're going to come in and then we're going to turn on an active bit. Now this is going to be a global bit we're going to use out throughout the program. This is going to be batch active status. So this is going to be utilized throughout the program, and it's going to be, all right, we don't even have to throw status on there. We can just say batch active for that matter. And then we'll keep it just that simple, right? So batch active. And then we want to come over here and throw we want to throw a stop push button. Now the stop push button too, so let's come in here and do a seal in circuit again. Very easy to understand what a seal-in circuit is. It's basically one shot, or it's basically coming in and sealing something in, and then when you break it, it will, shut it off. And we'll show that being indicated right here. We're going to come in and let me show you that again. As we're going to grab a examine off, and in examine off, we're going to create a new tag, and this will be HMI stop or batch stop PB. Again, we're going to keep it as control level or controller scope, and we're going to just finalize that. So now we have everything working, or we have everything in there that we want to have. I know it seems like we could do this a lot simpler, but let me explain why we are doing it this way, right? So when it comes down to it, you're going to have this HMI button, right? So the HMI start push button is going to be on the HMI screen when we put it on there, and it's going to throw a active over here. It's going to control that one boolean on. When that boolean cuts on, it's going to cut on this one shot. It's going to turn on the timer. The timer again will be active and stay active by the timer timing, and then when it is done, it's going to seal in this batch active bit. And as long as the stop push button has not been pressed, it will stay in. So to test that, we are online. We want to come in here and toggle this, and we can see it working. So now you see it working. Now if I hit the stop button, it will unseal this bit. Now, for the sake of what we're doing, see this one shot? This is the exact reason why I did this way. So if somebody were to hold the button on, or if you had a communication lapse, if you have some kind of something with your HMI that failed to work, or a HMI sticky button, or something of that nature where the button sticks into a state that is uncontrollable, then what you can do is have a one shot right here, just like I just showed. So it would have to be depressed again and then started again before it actually worked. So this is the reason why we do this way. It may seem like it's a lot of work, it may seem like it's not functional, or it could be done a lot simpler, but there's a lot of thought pattern behind why we're doing what we're doing, and why, the components behind it, right? So if there's a problem with just for simplicity's sake, if there's a problem with the HMI communication, or if there's a problem with the HMI touchscreen, or if there's a problem with, say, if you're using a laptop or a thin client or something of that nature, if there's a problem with any of that, because the world of tying systems and integrations together is very, very diverse. If there's any kind of problem and that bit stays high or doesn't come on, then we need to have a fail safe, right? So with that said, same thing, we can put in HMI sticky button controls, so we can do that as well. But again, when it comes down to it, I have YouTube videos on that as well. But when it comes to it, that's a lot of stuff when you can just do this way. Now we want to come in and do a rung comment. So we're going to do a rung comments now. And in rung comments, we're going to do, this is what I like to do. I like to come in, do brackets, and then I'll do HMI start push button. Let's see, push button logic. So I'll do that. And the reason I put these basically this brackets around it, so it kind of stands out. It's really, really bold. You can see what it does. Simple thing right here, I'll do the same thing, is add another rung. And the rung edits, again, are there. The same thing as having descriptions. They will not come in if you upload, but if you have a copy of the program, they're very valuable. They help you. They help the programmer as they're programming through this. So as you're building your stuff out, you need to kind of go back and understand why you did what you did sometimes. So this is the reason why I put this in there. And we'll say this rung controls the delay to start the batch active bit. And then we'll do that. So we'll have a nice little pop out there that kind of you can see the way it works, right? And then we'll say this last one, we'll give an indicator that says this is the global object. This rung controls the global batch. Let's just say the batch active bit, which will be used throughout the programs, aka global usage. So I like to give as much information as I possibly can if I'm writing this out. And you do see I spell batch wrong again. I so much apologize for that. My fingers are not working today for the life of me. But the reason I like to put in this much information in here is so that the person behind me can see this, right? You don't have to put this in there. You don't have to put brackets in here. You don't have to put even comments in here if you don't want to. Now, this is completely up to you. I do like to do this in the case of what I'm doing because it helps them, right? I do sometimes come in and, like, if I'm just starting the rung is I'll just have this just like this. The only reason I put the brackets is a good separator. So if I know, for instance, just like this, if I know the indicators just like this, right? So this does give you a good breaking point, and it does highlight this is for this rung, this is for this rung, and this is for this rung. So, you know, that's the reason why I'm doing the brackets, right? So, but it kind of looks awkward right here, to be honest with you. So that's why I put the brackets on the very bottom. So just like that, then I'll hit the save button, and now we have a global bit that we can use throughout our program. And you know the reason why, right? So we're utilizing that so we can have, you can use this batch active in the premix, the mixer, the finished tanks, the mixing motor controls, the flow meters, or whatever you want to use. And you can even use it in your alarming and stuff of that nature. So you have one bit you can use throughout the whole program and save you time from actually utilizing that somewhere else, right? Or having to recreate that atmosphere. Now I know this video ran long, but again, very much there's a lot of information in here, a lot of data, a lot of understanding behind what we did and why we did it. So if you need to, please watch this video again, because it does give you a lot of understanding of basic principles, why we're doing what we're doing, and to give you the best practices that I've seen over the 18 years that I have been programming and working with stuff, right? I have been able to take systems that have not been user-friendly and make them user-friendly so that they work more efficiently, and it ultimately increases the OEE, the operating efficiency of that piece of equipment, right? So with that said, that has saved companies millions and millions of dollars over the years, and I want to make sure that you're able to understand how to do this and how to understand why I'm doing what I'm doing. So give you a proper foundational element, you know, not just programming itself, but understand why we're doing what we're doing, right? Anybody can say, oh, here's a bit, start, stop, do this, do that. I want to tell you why and why I'm doing it. So hopefully you're getting a lot out of this and you understand why. I'm sorry that the video ran long. I do understand what it's like to watch videos like this, so I appreciate your, you know, if you have to stop, please stop, rewatch the video, come back in any section you feel like you need to come back and revisit, write down the times, write down the section, go back to that time and section and rewatch it, take notes as you're going through it, because again, a lot of this stuff is highly valuable, and it took me years to understand myself, and once I did, I implemented these things and they were successful. So with all that said, we'll see you guys on the next one.